Binary star systems are some of the most common types of stellar systems in the universe. They consist of two stars that are gravitationally bound to each other and orbit around a common center of mass. In this article, we will explore the characteristics of binary star systems and the process of their evolution. Characteristics of binary star systems. Binary star systems can have a variety of characteristics, depending on the masses and distances between the stars. Some binary systems have stars that are very close to each other, while others have stars that are separated by large distances. Binary stars can also have different types of orbits, including circular, elliptical, and even chaotic orbits. One of the key characteristics of binary star systems is their influence on each other's evolution. The gravitational interaction between the two stars can lead to a variety of effects, such as tidal forces that cause the stars to become distorted over the transfer of mass between the stars. These effects can significantly alter the evolution of the stars and the eventual fate of the system. Evolution of binary star systems. The evolution of binary star systems depends on a variety of factors, including the masses and ages of the stars, the separation between the stars, and the amount of mass transfer between the stars. One common scenario for the evolution of binary star systems involves the transfer of mass from one star to the other. In some cases, the more massive star can transfer material to its companion, causing the companion to become a white dwarf or a neutron star. If the transfer of mass is particularly rapid, it can also lead to the formation of a type of supernova known as a type Ia supernova. In other cases, the two stars can evolve separately and eventually become white dwarfs or neutron stars on their own. These stars can then interact gravitationally with other stars or objects in the universe, leading to a variety of interesting phenomena such as accretion disks and gravitational waves. In addition to binary star systems, there are many other interesting topics related to the study of stars and their evolution. Here are a few more examples. Stellar evolution. Stellar evolution is the process by which stars change over time. It involves a wide range of phenomena, including nuclear fusion, stellar winds, and supernova explosions. By studying the evolution of stars, astronomers can learn more about the structure and behavior of these fascinating objects. Variable stars. Variable stars are stars that undergo changes in brightness over time. They can be used as important tools for studying the properties of stars and their environments, as well as for measuring distances in the universe. Star clusters. Star clusters are groups of stars that are held together by their mutual gravitational attraction. They can be used to study the properties of stars and their formation and evolution, as well as to probe the structure and dynamics of galaxies. Stellar populations. Stellar populations refer to the different types of stars that exist within a galaxy or other astronomical object. By studying the distribution and properties of stellar populations, astronomers can learn more about the formation and evolution of galaxies and the structures within them. Stellar archaeology. Stellar archaeology is the study of the oldest stars in the universe. These stars can provide valuable insights into the early history of the universe and the formation of the first galaxies. Binary star systems are characterized by two stars that are gravitationally bound to each other and orbit around a common center of mass. They can have a variety of characteristics depending on the masses and distances between the stars. One important characteristic of binary star systems is the distance between the two stars, which can range from a few 100,000 kilometers to several light-years. Binary systems with close stars are called close binaries or contact binaries, and those with widely separated stars are called wide binaries or detached binaries. The distance between the stars can have a significant effect on the evolution of the binary system. Another important characteristic of binary star systems is the mass of the stars. Binary stars can be made up of two stars that are similar in mass, or they can have one star that is significantly more massive than the other. The mass of the stars can affect the orbit of the binary system, as well as the eventual fate of the stars. The orbit of the binary system can also vary in shape. Some binary systems have a circular orbit, while others have an elliptical orbit. In some cases, the orbit of the binary system can be highly eccentric or even chaotic. Binary star systems can also have different types of stars, such as main sequence stars, white dwarfs, neutron stars, or black holes. These different types of stars can interact in complex ways, leading to a variety of phenomena such as accretion disks, supernovae, or gravitational waves. The interaction between the stars in a binary system can also have a significant effect on their evolution. For example, the stars can exchange mass with each other, leading to the formation of exotic objects like black holes or neutron stars. The gravitational interaction between the stars can also cause them to become distorted, leading to the formation of tidal bulges or even the eventual merging of the stars. Overall, binary star systems are fascinating objects that provide valuable insights into the properties and behavior of stars. By studying these systems, astronomers can learn more about the evolution of stars and the formation of complex structures like galaxies. Star clusters are groups of stars that are held together by their mutual gravitational attraction. They can be classified into two main types: open clusters and globular clusters. Open clusters, also known as galactic clusters, are groups of young stars that are relatively loosely bound together. They typically contain a few hundred to a few thousand stars and are found in the disk of a galaxy, particularly in spiral galaxies. Open clusters are typically less than a few 100 million years old and are actively forming new stars. Because they are relatively young and contain stars of similar ages and compositions, open clusters are important for studying the formation and evolution of stars. Globular clusters, on the other hand, are much more tightly bound and contain a much larger number of stars, typically hundreds of thousands to millions. They are spherical in shape and are found in the halo of a galaxy, particularly in elliptical galaxies. Globular clusters are much older than open clusters, with ages typically ranging from 10 to 13 billion years old. Because they are composed of stars that formed early in the history of the universe, globular clusters are important for studying the early evolution of galaxies and the structure of the universe. Both open and globular clusters are important for studying the properties of stars and their evolution. By studying the stars in a cluster, astronomers can learn more about the age, composition, and structure of the stars, as well as their eventual fate. The universe is constantly changing over time. From the formation of the first stars and galaxies to the present day, the universe has undergone many transformations that have shaped the cosmos as we know it. In this article, We will explore some of the key changes that have occurred in the universe over time and the process of measuring distances between celestial objects. The Big Bang. The universe is believed to have begun with the Big Bang, an explosive event that occurred approximately 13.8 billion years ago. During the Big Bang, the universe rapidly expanded and cooled, eventually forming the first stars and galaxies. The formation of stars and galaxies. Over time, the first stars and galaxies formed from clouds of gas and dust. As these objects formed, they began to interact and merge, leading to the formation of larger and more complex structures. The expansion of the universe. One of the most significant changes in the universe over time is the expansion of the universe itself. This expansion was first observed by astronomer Edwin Hubble in the 1920s, who noticed that distant galaxies appeared to be moving away from us at increasing speeds. This observation led to the development of the theory of the expanding universe, which suggests that the universe is growing larger and larger over time. Measuring distances in the universe. Measuring distances between celestial objects is a challenging task that requires a variety of techniques. One of the most commonly used techniques is called parallax, which involves observing a celestial object from two different positions on Earth and measuring the apparent shift in position of the object. This technique can be used to determine the distance to nearby stars and other objects in our own galaxy. For more distant objects, astronomers use a variety of other techniques, including standard candles and redshift. Standard candles are objects whose brightness is well known, allowing astronomers to determine their distance based on how bright they appear in the sky. Redshift is a measure of how much the light from a distant object has been stretched due to the expansion of the universe. By measuring redshift, astronomers can determine how far away a galaxy or other object is from Earth. In addition to the changes in the universe over time and the process of measuring distances between celestial objects, there are many other interesting topics related to the study of the cosmos. Here are a few more examples. Dark energy. Dark energy is a mysterious force that is causing the expansion of the universe to accelerate. It makes up about 68% of the total mass energy of the universe, but its nature and properties are still poorly understood. Cosmic microwave background radiation. The cosmic microwave background radiation is the residual heat left over from the Big Bang. It is a faint glow that can be observed in all directions in the sky and provides valuable insights into the early universe. Gravitational waves. Gravitational waves are ripples in spacetime that are produced by the movement of massive objects, such as black holes or neutron stars. They were first detected in 2015 and have opened up a new way of observing the universe. Exoplanets. Exoplanets are planets that orbit stars other than the Sun. They are of great interest to astronomers because they provide insights into the formation and evolution of planetary systems. The search for life. The search for life beyond Earth is a topic of great interest to many scientists. With the discovery of many exoplanets in recent years, the possibility of finding life elsewhere in the universe has become a real possibility. These are just a few more examples of the many interesting topics related to the study of the cosmos. As our understanding of the universe continues to expand, we are sure to discover even more fascinating phenomena and insights into the workings of the cosmos. There are many other fascinating topics related to the study of the cosmos. Here are a few more examples. The formation of the solar system. The formation of the solar system is a topic of great interest to astronomers. By studying the planets, moons, asteroids, and other objects in our own solar system, scientists hope to gain insights into how planetary systems form and evolve. The multiverse. The idea of a multiverse suggests that our universe is just one of many possible universes that exist. This concept is still highly speculative, but it is an area of active research in theoretical physics and cosmology. Black holes. Black holes are regions of space where the gravitational pull is so strong that nothing, not even light, can escape. They are some of the most fascinating and mysterious objects in the universe, and their properties and behavior are still being studied today. The origin of life. The origin of life on Earth is a topic of great interest to many scientists. By studying the conditions on early Earth and the building blocks of life, researchers hope to gain insights into how life may have originated and evolved. Dark matter. Dark matter is a hypothetical form of matter that is believed to make up a large portion of the universe's mass. It does not interact with light or other forms of electromagnetic radiation, so it cannot be directly observed. However, its presence can be inferred by its gravitational effects on visible matter. The Big Bang is the scientific theory that describes the origin of the universe. It is believed to have occurred approximately 13.8 billion years ago and marks the beginning of the expansion of the universe. The Big Bang theory is supported by a large body of evidence, including observations of the cosmic microwave background radiation. The abundance of light elements in the universe, and the redshift of distant galaxies. According to the Big Bang theory, the universe began as a singularity, a point of infinite density and temperature, that rapidly expanded and cooled. In the first few moments of the Big Bang, the universe underwent a period of exponential expansion known as cosmic inflation. During this time, the universe grew exponentially larger, increasing in size by a factor of at least 10 to the power of 26 in just a fraction of a second. As the universe expanded and cooled, matter and energy began to form. Within the first few minutes of the Big Bang, the universe became cool enough for protons and neutrons to form from the initial energy of the singularity. These protons and neutrons then combined to form the nuclei of the lightest elements, hydrogen, helium, and lithium. Over the next hundreds of millions of years, the universe continued to cool and expand.
The formation and evolution of galaxies. Galaxies are among the most fascinating and awe-inspiring objects in the universe. They come in a variety of shapes and sizes, and are the building blocks of the cosmos. But how did they form and evolve into the diverse structures we see today? In this article, we will explore the formation and evolution of galaxies, from the early universe to the present day. Formation of galaxies. The current consensus among astronomers is that galaxies form through the process of hierarchical clustering. This theory proposes that small structures, such as dwarf galaxies and globular clusters, formed first and then merged over time to create larger and more massive galaxies. The formation of the first galaxies likely occurred around 13 billion years ago, shortly after the Big Bang. One of the key ingredients in galaxy formation is dark matter, a mysterious substance that makes up about 85% of the universe's matter. Dark matter is thought to provide the gravitational glue that holds galaxies together and enables them to form in the first place. As small structures merge, their dark matter halos combine and grow, eventually forming the massive halos that surround galaxies today. Evolution of galaxies. After galaxies formed, they continued to evolve and change over billions of years. One of the most important factors in galaxy evolution is the interplay between dark matter, gas, and stars. As galaxies grow and merge, they can trigger bursts of star formation, which consume gas and produce new stars. Over time, the gas reservoirs of galaxies are depleted, and star formation slows down. Galaxies also undergo a process called morphological transformation, where their shape and structure change over time. For example, a spiral galaxy like our Milky Way may merge with another galaxy and become an elliptical galaxy. This process can happen multiple times over the course of a galaxy's lifetime, leading to a rich diversity of galaxy shapes and sizes. Observing galaxies. Astronomers study galaxies using a variety of techniques, including telescopes that detect light across the electromagnetic spectrum. For example, visible light telescopes like the Hubble Space Telescope can capture stunning images of galaxies, while radio telescopes can detect the faint signals emitted by gas and dust in the interstellar medium. By observing galaxies at different wavelengths, astronomers can learn about their composition, structure, and history. In addition to the information presented above, it's worth noting that galaxies are not distributed randomly throughout the universe. Instead, they tend to form in clusters and superclusters, which are themselves part of even larger structures known as filaments and walls. These large-scale structures are thought to have formed through the same hierarchical clustering process that gave rise to individual galaxies. Another interesting aspect of galaxy formation and evolution is the role of black holes. Supermassive black holes are thought to be present at the centers of most galaxies, and their growth and activity can have a profound effect on their host galaxy. For example, black holes can release huge amounts of energy through jets and outflows, which can heat and disrupt the gas in the surrounding galaxy, influencing its evolution. Finally, it's worth noting that the study of galaxies is not just a theoretical pursuit. Understanding the properties and evolution of galaxies is important for a variety of practical applications. From interpreting astronomical observations to testing models of the universe's structure and history. Additionally, the study of galaxies can shed light on broader topics such as the formation of stars and planets, the evolution of life, and the nature of dark matter and dark energy. The formation of galaxies is a complex and ongoing area of research in astrophysics. One of the prevailing theories of galaxy formation is hierarchical clustering, which suggests that galaxies formed through the merging of smaller structures. In the early universe, matter was distributed more evenly than it is today. However, small perturbations in the distribution of matter caused regions of slightly higher density to form. These regions then began to collapse under the force of gravity, forming the first galaxies. Dark matter played a critical role in the formation of galaxies. Dark matter is a form of matter that does not interact with light and can only be detected through its gravitational effects. It is thought that dark matter provided the scaffolding on which galaxies formed, with gas and stars eventually filling in the gaps. As galaxies formed, they began to merge with each other, creating larger and more massive structures. These mergers also triggered bursts of star formation, which produced the bright, massive stars that are visible in many galaxies today. Over time, the gas reservoirs of galaxies were depleted, and star formation slowed down. Galaxies also underwent a process of morphological transformation, where their shape and structure changed over time. For example, a spiral galaxy like our Milky Way may merge with another galaxy and become an elliptical galaxy. While hierarchical clustering is the current leading theory of galaxy formation, there are still many unanswered questions. For example, it is not clear how the first galaxies formed from the initial density perturbations in the early universe, or how the properties of galaxies are related to the properties of the dark matter halos that surround them. Advancements in observational technology and computer simulations are helping astronomers to better understand the formation of galaxies. By studying the properties of galaxies at different distances and epochs, researchers can piece together the history of galaxy formation and evolution, and shed light on some of the most fundamental questions about the universe. The evolution of galaxies is a complex process that takes place over billions of years. After galaxies form, they continue to change and evolve as they interact with their environment and with other galaxies. One of the most important factors in galaxy evolution is the interplay between dark matter, gas, and stars. As galaxies grow and merge, they can trigger bursts of star formation, which consume gas and produce new stars. Over time, the gas reservoirs of galaxies are depleted, and star formation slows down. This is thought to be due to a combination of factors, including feedback from supernovae.
The universe is vast and mysterious, full of wonders that continue to baffle even the most brilliant minds. In this article, we'll explore some of the most bizarre and unexplained phenomena in astronomy and astrophysics. Fast radio bursts, FRBs. Fast radio bursts are intense bursts of radio waves that last only a few milliseconds but emit more energy than the sun does in a month. These bursts are so bright that they can be detected from billions of light-years away. Despite being discovered over a decade ago, the source of these mysterious signals remains unknown. Some theories suggest they could be the result of neutron star collisions or alien technology. Dark matter. Dark matter is an invisible substance that makes up about 85% of the matter in the universe. Its existence was first hypothesized in the 1930s, but it has yet to be directly observed. Its presence is inferred by its gravitational effects on visible matter. The nature of dark matter remains one of the biggest mysteries in modern astrophysics. Dark energy. Dark energy is another enigmatic substance that makes up about 68% of the universe. It's believed to be responsible for the accelerating expansion of the universe, but its nature is unknown. Some theories suggest it could be a new fundamental force or an unknown property of space itself. Cosmic microwave background radiation, CMB. The cosmic microwave background radiation is the afterglow of the Big Bang. It's the oldest light in the universe and has been traveling for over 13 billion years. It's also incredibly uniform, with temperature variations of only a few millionths of a degree. The origin of these tiny variations is still a mystery, but they provide valuable clues about the universe's early history. Black holes. Black holes are some of the most bizarre objects in the universe. They're regions of space where gravity is so strong that nothing, not even light, can escape. They're also incredibly dense, with a mass equivalent to billions of suns packed into a space the size of a city. Despite their bizarre properties, black holes are essential to our understanding of the universe's evolution. The wow signal. In 1977, a radio telescope detected a strong signal from deep space that lasted for 72 seconds. The signal was so unusual that the astronomer who discovered it wrote "wow" in the margin of the printout. Despite numerous follow-up observations, the source of the signal remains unknown. Some theories suggest it could be a message from extraterrestrial intelligence, while others suggest it was simply a natural phenomenon. Galactic cannibalism. Galactic cannibalism is a phenomenon where one galaxy consumes another, either by merging with it or by tearing it apart through gravitational forces. This process can take billions of years and can result in the formation of new stars and the restructuring of the galactic structure. However, scientists are still trying to understand the precise mechanisms that govern this process, and how it affects the evolution of galaxies over time. The Pioneer Anomaly. The Pioneer Anomaly refers to a phenomenon where the Pioneer 10 and 11 spacecraft, launched in the 1970s, experienced a slight but unexplained deceleration as they traveled through space. This deceleration, which was only detected after years of travel, cannot be explained by known physical laws and has puzzled scientists for decades. Some theories suggest that it could be due to new physics, while others suggest it could be due to the uneven distribution of heat on the spacecraft. The Kuiper Belt. The Kuiper Belt is a region of space beyond Neptune's orbit that contains thousands of small icy objects, including dwarf planets such as Pluto. However, the Kuiper Belt structure and origin are still a mystery. Some theories suggest that it could be the remnants of the early solar system, while others suggest that it could be the result of a gravitational interaction with a passing star. Magnetars. Magnetars are a type of neutron star with an extremely powerful magnetic field. These magnetic fields are so strong that they can warp spacetime and generate powerful bursts of energy that can be detected across the universe. However, scientists are still trying to understand how these magnetic fields are generated, and how they can remain stable over time. In summary, the universe is full of strange and unexplained phenomena that continue to challenge our understanding of the cosmos. From the fast radio bursts to magnetars, these phenomena remind us that there is still so much we have yet to discover about the universe we inhabit. As we continue to explore and study the cosmos, we're sure to uncover even more mysteries that will keep us fascinated for generations to come. Fast radio bursts, FRBS, are one of the most mysterious and fascinating phenomena in modern astrophysics. They are intense bursts of radio waves that last only a few milliseconds, but emit more energy than the sun does in a month. The first FRB was detected in 2007, and since then, hundreds more have been observed, most of them coming from outside of our galaxy. One of the most intriguing aspects of FRBS is their origin. Despite being detected for over a decade, the source of these signals remains unknown. Scientists have proposed several theories to explain the phenomenon, but none have been conclusively proven. Some of the most popular theories include neutron star collisions. Neutron stars are incredibly dense objects that form when a massive star undergoes a supernova explosion. When two neutron stars collide, they can produce a burst of radiation that could be detected as an FRB. Magnetars. Magnetars are a type of neutron star with an extremely powerful magnetic field. Some scientists have proposed that FRBs could be generated by magnetars when their magnetic fields interact in a violent way. Alien technology. While it's unlikely that FRBs are the result of extraterrestrial intelligence, some scientists have suggested that the signals could be artificial in nature. Despite the lack of a clear explanation, FRBs are a valuable tool for studying the universe. By analyzing the properties of these bursts, scientists can learn more about the structure of the universe, the nature of dark matter, and the early history of the cosmos. In addition, studying FRBs can help us develop new technologies for detecting and analyzing cosmic signals, which could have important applications in astronomy, astrophysics, and beyond. While we still have much to learn about FRBs, one thing is clear: they are one of the most fascinating and enigmatic phenomena in the universe. As we continue to study and explore the cosmos, we're sure to uncover even more mysteries that will keep us captivated for generations to come. The solar system is a complex and dynamic system, where the planets and the comets interact with each other in various ways. Comets are small celestial bodies that are composed of ice, dust, and gas, and they orbit around the Sun in highly elliptical orbits. When a comet approaches the Sun, it heats up, and some of its material is vaporized, creating a glowing coma and a tail that points away from the Sun. In this article, we will explore the interaction between planets and comets and the phenomenon of comets in the night sky. One of the most fascinating aspects of comets is their interaction with planets. When a comet passes close to a planet, its trajectory can be altered due to the planet's gravity. This can result in the comet being ejected from the solar system, captured by the planet's gravity and become a moon, or sent into an orbit that brings it back to the inner solar system. The most famous example of this phenomenon is Halley's Comet, which is named after the English astronomer Edmund Halley. Halley predicted that the comet he observed in 1682 would return in 1758, and it did. The next appearance of Halley's Comet is predicted to be in 2061. Comets can also have an impact on planets. When a comet collides with a planet, it can create a crater or cause a massive explosion, depending on the size and speed of the comet. The most famous example of this is the Tunguska event, which occurred in 1908 in Siberia, Russia. It is believed that a comet or asteroid exploded in the atmosphere, causing a blast that was equivalent to 10 to 15 megatons of TNT. Which is more powerful than the most powerful nuclear weapon ever detonated. The phenomenon of comets in the night sky has fascinated humans for thousands of years. Comets were often viewed as omens of doom or signs from the gods. Today, we know that comets are natural phenomena that occur regularly in our solar system. However, they are still a rare and beautiful sight to behold. The best time to observe a comet is when it is closest to the Sun, as it will be at its brightest and have the longest tail. Comets can be seen with the naked eye, but a telescope or binoculars can enhance the viewing experience. In addition to their scientific significance, comets also hold cultural and historical significance. Throughout history, comets have been associated with major events and have inspired artistic works, literature, and myths. For example, the Bayeux Tapestry, an embroidery depicting the Norman conquest of England in 1066, includes a depiction of Halley's Comet in the sky, which was visible at that time. The famous Shakespearean play Hamlet also references a comet, which was visible in 1607. The study of comets has also led to important discoveries and advancements in astronomy. In 2014, the Rosetta spacecraft became the first spacecraft to orbit a comet and land on its surface. This mission provided valuable information about the composition and structure of comets, which can help scientists understand the formation and evolution of the solar system. The interaction between planets and comets and the phenomenon of comets in the night sky are fascinating and important areas of study in astronomy. By exploring these topics, we can gain a deeper understanding of the complex and dynamic nature of our solar system and its history. Moreover, the study of comets has cultural, historical, and scientific significance, making it a fascinating subject for astronomers and the general public alike. Another interesting aspect of comets is their potential to provide insights into the origins of life on Earth. Comets are believed to contain organic molecules, such as amino acids, which are the building blocks of life. These molecules may have been delivered to Earth by comets, providing the raw materials for the development of life. Moreover, comets have been observed around other stars, which suggests that they may be common in other planetary systems. The study of comets in other systems can help us better understand the formation and evolution of those systems, and may provide clues as to whether life exists elsewhere in the universe. In addition to their scientific and cultural significance, comets are also important for space exploration. Comets have been proposed as potential targets for future space missions, such as sample return missions, which could bring back samples of cometary material to Earth for analysis. In summary, the study of comets is a rich and fascinating area of research, with important scientific, cultural, and practical implications. Through ongoing observations and missions, we can continue to deepen our understanding of these enigmatic celestial bodies and their role in the evolution of our solar system and the universe as a whole. Comets are believed to have formed in the outer reaches of the solar system, in the Kuiper Belt and the Oort cloud. These regions are composed of icy bodies that were left over from the formation of the solar system. When a comet is perturbed from its orbit, it can be sent towards the inner solar system, where it becomes visible as a bright object in the night sky. As a comet approaches the Sun, it heats up, causing the ice on its surface to vaporize and creating a glowing coma, which is a fuzzy halo around the nucleus of the comet. The vaporized material also forms a tail that points away from the Sun, due to the solar wind, which is a stream of charged particles emanating from the Sun. Comets can have highly elliptical orbits, which means that they spend most of their time far from the Sun, in the outer reaches of the solar system. However, some comets have been observed to have very short periods, which means that they orbit the Sun in a matter of years or even months. These comets are believed to originate from the Kuiper belt or the scattered disk, which is another region of icy bodies beyond Neptune. Comets have been studied using a variety of techniques, including telescopic observations, space missions, and laboratory experiments. The Rosetta mission, which was launched by the European Space Agency in 2004, was one of the most ambitious missions to a comet. The mission involved a spacecraft orbiting the comet 67P/Churyumov-Gerasimenko for more than 2 years, and included a lander that touched down on the surface of the comet. The mission provided unprecedented data on the composition and structure of a comet, and helped scientists to better understand these enigmatic objects. In addition to the scientific significance of comets, they also hold cultural and historical significance. Comets have been observed and documented throughout history, and have been associated with major events and portents of doom. The ancient Greeks believed that comets were signs of impending disaster, while in medieval Europe, comets were associated with the Black Death and other calamities. However, in more recent times, comets have been viewed as fascinating and beautiful objects that inspire wonder and awe. Another interesting aspect of comets is their connection to meteor showers. Meteor showers occur when Earth passes through the debris left behind by a comet or asteroid. As the debris enters Earth's atmosphere, it vaporizes, creating a streak of light in the sky known as a meteor. Since the dawn of civilization, humans have been fascinated by the mysteries of the universe. Over the centuries, humans have developed various methods to explore and understand the cosmos. From observing the motions of the stars and planets, to developing sophisticated telescopes and spacecraft. Today, scientists continue to study the universe through surveys and scientific research, uncovering new insights into the nature and evolution of the cosmos. One of the most important tools for studying the universe is the survey. Surveys are large-scale studies that collect data from a large number of sources, such as telescopes or spacecraft. Surveys can cover a wide range of wavelengths, from radio waves to X-rays, and can provide valuable insights into the properties and behavior of objects in the universe. One of the most ambitious surveys currently underway is the Large Synoptic Survey Telescope, LSST, which is set to begin operations in the mid-2020s. The LSST is a ground-based telescope that will conduct a 10-year survey of the entire sky, producing a detailed map of the visible universe. The LSST will be able to detect and track objects that are too faint or too fast-moving to be seen by other telescopes, such as asteroids, comets, and supernovae. The survey is expected to produce a wealth of data that will be used to study the properties and evolution of galaxies, dark matter, and dark energy. Another important tool for studying the universe is scientific research. Scientists use a variety of methods to study the cosmos, including observations, experiments, and simulations. These methods allow scientists to test theories and models of the universe, and to gain insights into the behavior of objects in the universe. One of the most exciting areas of scientific research in the universe is the study of exoplanets. Exoplanets are planets that orbit stars outside our solar system, and have been discovered using a variety of methods, such as the transit method and the radial velocity method. Scientists are using these discoveries to study the properties and potential habitability of exoplanets, as well as to gain insights into the formation and evolution of planetary systems. In addition to exoplanets, scientists are also studying the properties and behavior of galaxies, stars, black holes, and other objects in the universe. By studying the properties and behavior of these objects, scientists can gain insights into the nature and evolution of the universe, and develop new theories and models to explain the observations. Another important aspect of our understanding of the universe is the use of space missions to explore and study objects in our solar system and beyond. Space missions allow scientists to gather data and make observations of objects that would be difficult or impossible to study from Earth. Some of the most important space missions in recent years include the Mars rovers, the New Horizons mission to Pluto, and the Kepler mission to study exoplanets. The Mars rovers, including the Curiosity rover and the upcoming Mars 2020 mission, have provided valuable insights into the geology and potential habitability of Mars. The rovers have collected samples, analyzed rocks, and taken high-resolution images of the Martian surface, providing valuable data for scientists studying the red planet. The New Horizons mission to Pluto provided the first close-up images and data of the dwarf planet and its moons. The mission revealed a diverse and geologically active world, with mountains, valleys, and vast plains of nitrogen ice. The mission also provided valuable data on the Kuiper Belt, a region of the solar system beyond Neptune that contains thousands of icy objects. The Kepler mission was a space telescope designed to search for exoplanets by detecting the slight dip in a star's brightness when a planet passes in front of it. The mission discovered thousands of exoplanets, many of which are in the habitable zone of their host stars. The Kepler mission has provided valuable data for scientists studying the properties and potential habitability of exoplanets, and has opened up a new era in the search for life beyond Earth. In addition to space missions, advances in technology and computing power have also revolutionized our understanding of the universe. Data from telescopes and other instruments can be analyzed using sophisticated algorithms and machine learning techniques, allowing scientists to make new discoveries and insights. One of the key advantages of space missions is that they allow scientists to make direct observations and measurements of objects in the solar system and beyond. Spacecraft can carry specialized instruments and cameras that can collect data on objects that would be difficult or impossible to study from Earth. For example, the Hubble Space Telescope has provided some of the most detailed and stunning images of distant galaxies, nebulas, and other objects in the universe. Its observations have allowed scientists to study the properties and behavior of these objects, and to develop new theories and models to explain their observations. Space missions have also allowed scientists to study the properties and potential habitability of other planets in our solar system, such as Mars and Saturn's moon Titan. Spacecraft such as the Mars rovers have provided valuable data on the geology, chemistry, and potential habitability of the red planet, while the Cassini mission to Saturn and its moons provided insights into the potential for life on Titan, which has lakes and seas of liquid hydrocarbons. In addition to space missions, advances in technology and computing power have also revolutionized our understanding of the universe. Telescopes and other instruments can now collect vast amounts of data, which can be analyzed using sophisticated algorithms and machine learning techniques. These tools allow scientists to detect and study objects that were previously invisible, such as dark matter and dark energy. The study of exoplanets has also been revolutionized by advances in technology and computing power. The Kepler mission, for example, was able to detect small dips in a star's brightness that were caused by the transit of a planet across the face of the star. This required sophisticated algorithms and statistical analysis to detect and confirm the existence of exoplanets, many of which are smaller than the Earth. Another area where surveys and scientific research have contributed to our understanding of the universe is in the study of cosmology. Cosmology is the study of the large-scale structure and evolution of the universe as a whole. One of the most important tools for studying cosmology is the cosmic microwave background, CMB, radiation. The CMB is a faint glow of radiation that pervades the entire universe, left over from the Big Bang. By studying the properties of the CMB, scientists can gain insights into the nature and evolution of the universe, such as its age, size, and composition. The Cosmic Microwave Background Explorer (COBE) and the Wilkinson Microwave Anisotropy Probe (WMAP) were two missions that studied the properties of the CMB. These missions provided valuable data on the structure and composition of the early universe, and helped to confirm many of the predictions of the Big Bang theory. Another important tool for studying cosmology is the use of large-scale surveys to map the distribution of galaxies and dark matter in the universe. Surveys such as the Sloan Digital Sky Survey, SDSS, and the Dark Energy Survey, DAY, have provided valuable data on the large-scale structure of the universe, including the distribution of galaxies and the properties of the cosmic web. The study of gravitational waves is another exciting area of cosmology that has been revolutionized by surveys and scientific research. Gravitational waves are ripples in the fabric of spacetime that are caused by the acceleration of massive objects, such as black holes and neutron stars. The Laser Interferometer Gravitational Wave Observatory, LIGO, and the Virgo collaboration have detected gravitational waves from several sources, including the merger of two black holes and the collision of two neutron stars. The solar system is a complex system of celestial objects that interact with each other through gravity and other forces. Planets, moons, asteroids, comets, and other small celestial objects all play a role in the dynamics of the solar system. Understanding the interactions between these objects is important for understanding the history and evolution of the solar system. One important interaction in the solar system is between planets and asteroids. Asteroids are small, rocky objects that orbit the Sun, primarily in the asteroid belt between Mars and Jupiter. Occasionally, asteroids can collide with planets, causing significant damage. The most famous example of this is the asteroid impact that caused the extinction of the dinosaurs 65 million years ago. However, asteroids can also have a positive impact on planets. The impact of asteroids can create craters that can provide valuable insights into the geological history of planets. For example, the Chicxulub crater in Mexico, created by the impact that caused the extinction of the dinosaurs, has provided valuable information about the mass extinction event. Another important interaction in the solar system is between planets and comets. Comets are icy objects that orbit the Sun, primarily in the outer solar system. As comets approach the Sun, they heat up and release gas and dust, creating a characteristic tail. Comets can occasionally collide with planets, but these impacts are generally less destructive than asteroid impacts. Comets can also have a positive impact on planets. The water and organic compounds found in comets may have played a role in the formation and evolution of life on Earth. Scientists believe that comets may have delivered the water and organic compounds necessary for life to form on our planet. Moons are another important component of the solar system. Moons are natural satellites that orbit planets, and they play a significant role in the dynamics of the solar system. Moons can influence the rotation and tilt of planets, and can create tides that shape the geological features of planets. For example, the Moon's gravitational influence on Earth creates ocean tides that play an important role in the ecology of our planet. Another important interaction between planets and small celestial objects in the solar system is the role of gravitational perturbations. Gravitational perturbations occur when two or more celestial objects interact gravitationally, causing changes in their orbits and trajectories. For example, the gravitational influence of Jupiter has significant effects on the orbits of other planets and small celestial objects in the solar system. Jupiter's massive gravitational field causes gravitational perturbations that can alter the orbits of nearby asteroids and comets, sending them on new trajectories and potentially causing collisions with other objects. Gravitational perturbations can also play a role in the formation and evolution of the solar system. The gravitational interactions between planets, asteroids, and comets can cause them to collide and merge, forming larger objects. These interactions may have played a significant role in the formation of the solar system and the evolution of its constituent objects. Another important interaction between planets and small celestial objects is the role of planetary migration. Planetary migration occurs when a planet's orbit changes over time due to gravitational interactions with other objects in the solar system. This can occur due to interactions with other planets, asteroids, and comets. Planetary migration can have significant effects on the dynamics of the solar system. For example, some scientists believe that the migration of Jupiter and Saturn may have played a role in the formation of the asteroid belt. The gravitational interactions between these planets and nearby asteroids may have disrupted the orbits of the asteroids, causing them to collide and merge, eventually forming the asteroid belt. Gravitational perturbations occur when two or more celestial objects interact gravitationally, causing changes in their orbits and trajectories. These interactions are governed by Newton's law of gravitation, which states that the force of gravity between two objects is directly proportional to their masses and inversely proportional to the square of the distance between them. The gravitational influence of Jupiter is particularly significant in the solar system. Jupiter is the largest planet in the solar system and has a massive gravitational field that can significantly influence the orbits of nearby objects. This has led to the creation of a region of space known as the Trojan asteroids, which are located at Jupiter's Lagrange points, where the gravitational forces of Jupiter and the Sun balance each other. Gravitational perturbations can also cause small celestial objects to collide with planets or other objects in the solar system. The impact of a small object, such as an asteroid or comet, can have significant effects on a planet's surface and atmosphere. For example, the impact that caused the Chicxulub crater in Mexico 65 million years ago is believed to have caused the mass extinction of the dinosaurs. Planetary migration is another important interaction between planets and small celestial objects in the solar system. Planetary migration occurs when a planet's orbit changes over time due to gravitational interactions with other objects in the solar system. This can occur due to interactions with other planets, asteroids, and comets. The migration of planets can have significant effects on the dynamics of the solar system. For example, some scientists believe that the migration of Jupiter and Saturn may have played a role in the formation of the asteroid belt. The gravitational interactions between these planets and nearby asteroids may have disrupted the orbits of the asteroids, causing them to collide and merge, eventually forming the asteroid belt. The study of gravitational perturbations and planetary migration is important for understanding the dynamics and evolution of the solar system. By studying these interactions, astronomers can gain insights into the formation and evolution of celestial objects, as well as the processes that shape the evolution of the universe. These interactions can also provide valuable information about the potential risks posed by asteroids and comets, and inform efforts to mitigate those risks. Another important aspect of the interaction between planets and small celestial objects in the solar system is the role of collisions and impacts. Collisions and impacts between objects in the solar system have played a significant role in the history and evolution of the solar system. Collisions and impacts can occur between planets, moons, asteroids, and comets. These collisions can have significant effects on the structure, composition, and dynamics of the objects involved. For example, collisions between asteroids can result in the formation of larger asteroids or the creation of dust and debris. The impact of large asteroids or comets on planets can cause significant damage, including the formation of craters and the release of dust and debris into the atmosphere.